Okay, let's work on a mixture problem. So again, we've seen bits and pieces of this in the expressions chapter, but we're going to put it all together and build equations that we can solve in this section. So we're working on a mixture. We have 10 ounces of a solution that's 40% plant fertilizer, and we have another solution that's 50% plant fertilizer. And we're trying to figure out how much of the 50% solution do we have to add to the 40% solution if we want to get a 46% solution. So you sometimes see people draw these little mixed pictures, and you're welcome to if you want to. So we have 40% solution and we have 50% solution, and we're going to mix the two together to make 46% solution. We know we have 10 ounces of the 40% solution. We don't know how much 50%, and we don't know how much we're going to end up with. So this is a little different than I think some of the ones that we've done before in that way. So we get one variable. Often it's good to just use that to represent whatever you're specifically looking for. So here the question is, how much 50% solution do we add to create the 46% solution? So let's say X is the number of ounces of 50 ounces. Is that what we're, yep, 50% solution. So we can label this one with X ounces. Okay, so one thing I can see is if we have 10 ounces of 40% and we add X ounces of 50%, we're going to end up with a grand total of 10 plus X ounces of the 46% solution. The equation that we need to write isn't about the total amount of solution, it's about the total amount of fertilizer. So what we really have in here is we know that from the 40% solution, we get 4 ounces of pure fertilizer from the 40% solution. From the 50% solution, we get 0.5x ounces of pure fertilizer from that solution. And we know that we want to end up with 46%, and it would be 46% of the 10 plus, that's supposed to be an x, I see it turned into a z on me, x ounces. So what our equation tells us is that 46% of 10 plus x, this is the amount of pure fertilizer in the final mix, has to come from the fertilizer from the 40% and the fertilizer from the 50% solutions. So basically, if we take the 4 ounces of pure fertilizer from the 40% and the 0.5x ounces of pure fertilizer from the 50%, we have to get that total amount of fertilizer, pure fertilizer in the mixture. So our equation ends up being 4 plus 0.5x, and on the right hand side I'm going to go ahead and distribute. So I'm going to get 4.6 plus 0.46x. So we at least get a nice linear equation. Let's see, what can we do here? I'm going to move the x's to the left hand side. We have x's on both sides, so we need to get them on one side. So I get 4 plus 0.04x equals 4.6. Now that I have x on one side and I'm down to one of them, I just need to undo the multiplication by 0.04 and the addition of 4. So we'll first get rid of the plus 4 by subtracting. 0.4x equals 0.6. And then we'll get rid of the 0.04 by dividing. Okay, let's see. Let's move that decimal over twice. So we get 60 over 4. You could think of that as multiplying top and bottom by 100, which is what, 15? So 15. And again, think about what your answer means. That's the value of x. X is equal to 15 ounces. X was the amount of 50% fertilizer that we add if we want to bring the percentage up to 46. And just to think about if that makes sense or not, if we had 10 ounces of 40% and 10 ounces of 50%, we would end up with 20 ounces of 0.45, so 45%. So if they were the exact same amount, we would just average the percentages. So it makes sense that we need a little more of the 50% solution to bring it up above that midpoint of 45%. Hopefully that made sense. So I think I like it. And then I'm just going to go back and reread and make sure that was all I was looking for. I think it was. How much 50% solution should be added? Yep, so that is my answer. Okay, so hopefully that gives you another reminder about those mixture problems. Thanks for watching.